So this is Advanced Math, Unit 1, Lesson 1. We're going to talk about exponents and polynomial operations. So first let's go over the vocabulary. A monomial is when you have a constant, a variable, or a product of the constant and the variable. So what would be some examples? Well, a constant is just a number, so like 3. A variable is a letter, X, Y, Z, A, B, C. Now the product of the two means that you've multiplied them together. So it could be 3x, it could be 2xy, it could even be x over 2, where you don't normally think of a fraction as being a product. Where did that fraction come from? Well, it came from multiplying 1/2 times x. So that actually was a product. So you can have a fraction as the product of a constant and a monomial. Okay? Now let's look at the exponent rules. Before we talk about the exponent rules, let's backtrack and remember what exactly an exponent means. It tells you to do something. So let's compare a coefficient to an exponent. Now a coefficient actually tells you to do something. Where did 3x come from? What that actually means was x plus x plus x. Because remember, all of these actually have a coefficient of 1. You would add the coefficients. That's where the 3 came from. So the coefficient tells you how many times to add the variable. Alright, x to the third means x times x times x. So an exponent tells you how many times to multiply that base, because all of these actually have 1 for an exponent, and you would add them to get the 3. So I want you to keep that in your head. A coefficient tells you how many times to add this. An exponent tells you how many times to multiply it. Our first exponent rule is the product rule. So that means you're going to be multiplying two bases together that have exponents. And following the rule, what you do is you add the exponents. So for example, if I had x to the third times x to the 7th, I would add those and get x to the 10th. Why is that? Let's go ahead and explain it. Now what did I just tell you that an exponent tells you to do? It tells you to multiply. So what this expands out to is x 3 times 7 x's. Now, if you multiply all these together, what do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x to the 10. But you don't want to have to do that every time, so that's why these rules help you out. You could easily expand all these rules out, and it helps you understand them when you see it done once. But you don't want to have to write this out every time, so you need to memorize the fact that when you have x to the a times x to the b, you're just going to be adding those two together. Now let's look at the next one. Our next rule is the power rule, and that means you have a base with an exponent inside parentheses and another exponent outside. And the rule says when you have one base with two exponents, you just multiply those together. So if you have two bases, like we just did, both have an exponent, you're going to add the exponents. This time you're going to multiply. And you could expand this one out just like I did a minute ago. Well, let's get an example. Let's say this time I have x to the third to the 7th. So when you multiply those, you're going to get x to the 21st. Now why does it work to multiply? What you actually have is, first of all, in here you've got x times itself 3 times. And then you're going to have to multiply that out 7 times. So what that would look like is this. And then when you try to do it out 7 times, you're going to have 7 groups of 3. So what's 7 groups of 3? 21. But like I said, you don't want to expand this out every time. So your power rule is x to the a to the b is equal to x to the a times b. Our next rule is the quotient rule, and a quotient is a fraction. So this is what your problem would look like, similar to this. Your rule tells you that all you have to do now Since when you're multiplying, you add, what would you do for division? Well, we're going to subtract, okay? So let's just look at some examples. Let's say x to the 5th over x to the 3rd would be x to the 5 minus 3, so that's x squared. Now, why does that work? Well, what is x to the 5th? That's actually 5x's over 3x's, and what do you do when you have something over itself? It divides out to 1. So they're all going to cancel out until you've used up all of 1. And then what you have left is the extra. So how do you find extra? You subtract. The next one we're going to look at is negative exponents. Now, negative exponent means that that base is not happy on the side of the fraction bar that it's on. So the rule says if you have x to the negative a, what that actually means is 1 over x to the positive a. When you move it, the exponent becomes happy, so it gets positive again. Now, what if your negative exponent is on the bottom? Well, then it comes to the top. So this would be x to the a, okay? Let's think of some examples for this. I could have x to the negative 3, so that would convert to 1 over x to the positive 3. I could have 1 over y to the negative 2. I'm going to move the y up. There won't be anything left in the denominator. So that would be y to the positive 2. Now, it gets interesting when, let's say I have m to the 3rd over m to the 5th. What should I subtract first? It doesn't matter as long as you're consistent. If you always do top number minus bottom one, or top exponent minus bottom one, what are you going to get here? 3 minus 5 is m to the negative 2, which you would then convert to m to the positive 2. Or, what I always do when I have a fraction like this, I just always subtract the large number, or the small number from the large one, and then I put it on the same place as the largest number, the largest exponent. So if I do it this way, if I say 5 is larger, so I'm going to do 5 minus 3 is 2, and I'm going to put my remainder where the largest exponent was. So I have that. Well, you have to put something up in the place of it. So you can see the answer is the same. It's just two different ways to look at it. Okay, whichever way you want to do. If you want to always do top minus bottom and then convert, that's fine. If you want to always subtract large minus small and put it where the largest exponent was, that will always work. Our last rule is the zero exponent rule. Anytime you have a number raised to the 0 power, that is equal to 1. An example of that would be 2xy to the 0 power. That is equal to 1. Anything raised to the 0 power, 5x squared to the 0, is 1. Now, why is that? It's really easy when you remember your other rules. Let's just say I have x to the 3rd over x to the 3rd. So let's come at it from both ways. What is anything over itself? It's 1, right? All right, now let's use the exponent rule for a quotient. What would you do here? You would do x to the 3 minus 3, which is x to the 0, which is x to the 1, which is 1. So that's why anything raised to the 0 power is actually equal to 1. Okay? Now, let's work through some examples. Before we go into this first example, I want to go over these two things. The difference is they both have a base of 2, they both have an exponent of 2, they both have a negative sign. What is different is this one has no parentheses and this one does. Now what you get for an answer here is negative 4, because this exponent has very limited power. It can only affect its base, and the base is the thing that is just below it. So it's going to square the 2, but the negative still stays there. Now this time, since there's parentheses around the negative and the 2, that makes it one thing. So now that is your base. So what you actually have here is negative 2 times negative 2. So that can turn it to positive. All right. So what you need to remember is if you have an exponent, the only time it can change that base from negative to positive is if you have two things. You have to have the negative inside the parentheses and the exponent outside the parentheses. And the exponent has to be even, because if it's odd, it's just going to turn back to negative. So let's have a look at this first example with all that stuff in mind. So we look at this part first. We do have a negative raised to an exponent, but since this is not in parentheses, this is not going to affect the negative. It's still going to be negative. Now, what is 6 to the 4th? Well, this is going to be, I mean, you could do it quickly, but let's, practice using the calculator. Now, one thing I do want to remind you, on your calculator, the minus sign is not the same thing as the negative sign. This is your negative sign. This is your minus sign. So if you try to put that minus sign in there when you actually mean negative, it will give you the wrong answer. So the way I'd want to enter this in the calculator is I would put the negative button and then 6. Alright, hit the button that has the X with the little block to it. That's going to let you put that exponent there. So we're going to put 4, enter. So that gives us negative 1,296. Alright, now you can put this in the calculator or you could just do this in your head. Since it's a negative on the inside of the parentheses squared, it's going to change to positive. 1 squared is 1. Now when you have a fraction squared, that means you square both parts. So now I have 1/16. And here, that's just going to be negative 1296 divided by 16. So that would be negative 81. Problem 2 is a perfect example of one that you can go at it from a lot of different directions. So I'm going to start first. One of the things you need to take care of is your negative exponents. So I'm going to take care of this one first. When you have a fraction, a whole fraction that is raised to a negative exponent, the easiest way to change that to a positive is just to flip the whole fraction. So that's what I'm going to do. I'm now going to put the 5 to the 0 power on the bottom. This exponent doesn't change right now, but the 2 does change to a positive. Okay? So all this step did was take care of the negative 2 exponent. It changed it to a positive just by flipping that fraction. Now, let's go to the inside and see what we can do to simplify it. Or actually, let's distribute the exponent. That's going to be the easiest way to go here. When you have one exponent inside and one outside, you multiply. So 3 to the negative 1 squared is going to be 3 to the negative 2. And 5 to the 0 is, let's go ahead and make that 1. Anything to the 0 power. So now, the next thing to do is take care of this negative 3 squared. So since it's negative, it's got to go to the bottom. I'm going to put the 1 down here for now. That's going to bring this to the bottom and make the exponent positive. Now what's left up here? Well, you actually divided everything out, so there's a 1 there. Something has to hold the place. And then let's clean it up and simplify. What's 3 squared? 3 squared is 9 times 1 is 9. So, final answer is 1 over 9. Now yes, there's a lot of different ways you could have done something else first. You could have simplified the inside and then raised it to negative 2. So just because you don't do it in the same order that I did doesn't mean you did it wrong. There's so many different ways. So as long as you got the 1/9, you're good. Okay, let's look at our next problem. We've got negative 3p to the negative 2 times 8p to the 6th. Just to clarify, and you don't have to write this out, but I want you to understand, even though the multiplication sign is in the middle here, what you actually have is just all these numbers, and variables are just multiplied together, because 3 is multiplied times this, and 8 is multiplied times that, and nothing has priority over anything else. So now that we've got it separated out like this, and remember the negative 2 right here only goes to the p because it's not in parentheses. Alright, so what I'm going to do first is multiply my whole numbers together. Negative 3 times 8 is negative 24, and that just took care of those two things. So now let's look at these. Do I want to flip this now? Well, you could, but then you're going to have another step. So watch this. Since both of these bases match, what do you do when you multiply two bases together that have exponents? Well, you add the exponents, right? So if I just go ahead and add these, what's negative 2 plus 6? Well, that's 4. So you have p to the 4. What would have happened if you flipped this is you would have had the p to the 6th over p to the 2nd. It would have changed to positive when you put it on the bottom, but you still would have had to subtract, and you still would have wound up with this. So if you have negative exponents with positive exponents, go ahead and combine those, because that may take care of your problem. Your problem is you have a negative exponent, so however you can manage to get it positive is fine. Okay, let's look at the next one. For problem 4, we have 57x to the 4th, y to the negative 2, over 3x, y to the negative 3. So let's start here at the left and work our way through. 57 over 3 divides out evenly into 19. Now x to the 4th, remember this actually has an exponent of 1. When you have a fraction, you're going to subtract your exponents. So 4 minus 1 is 3. And you want to put your answer wherever your largest exponent is. So that takes care of those. Now, for these two, a lot of options. You can flip both of them and then subtract, or you can subtract as is. But now with both of them being negative, you're going to have to be careful, because what you actually have is negative 2 minus negative 3. So this would change to plus a positive. Negative 2 plus 3 is 1. So these cancel out. You have y to the 1 on top. So this would be your final answer. If you chose to flip them first, the y to the 3rd is going to come out on top. The y to the 2nd is going to go to the bottom. You're still going to subtract. Your largest exponent is still on top. So you still come out with the y. It's just however you want to look at it. Some people just don't get confused with all those negatives. When you subtract a negative, it's the same thing as adding a positive. Okay, when you're simplifying, you always need to keep in mind PEMDAS. That is, the rule of the day. And this cannot combine with this until I get this out of the parentheses. So how can you do that? Well, I'm going to have to distribute what's outside of it, which is this exponent, into here, and then I can multiply it times this. So let's take care of that first. This is not going to change at this point, so I'm just going to copy it down as it is. Now, when I bring this in here, when you square negative 4, that makes it positive 16. When you square r to the 3rd, that's going to give you r to the 6th. And when you square s, that'll give you s squared. So now, let's combine. 3/4 times 16 is 12. So that took care of those two. Then r to the negative 2 times r to the 6th. You're going to add. That's going to give you r to the 4th. And then these two is s to the 7th. That's all there was to it. Now yes, you could flip this and then subtract, but like I'm saying, if you have a base with a negative exponent multiplied times a base with a positive exponent, go ahead and combine those exponents first, because that may take care of your negative exponent problem. Okay, problem number 6 here. We've got negative 18 a to the 8th b to the 4th over negative 42 a to the 5th b to the 7th. Now there's nothing in here right now that's going to change that from a negative to a positive, so go ahead and put that. Alright, I'm going to draw my fraction bar. Now let's go through it one thing at a time. Remember, you can only work with 2 numbers at a time. So focus on that. Don't look at the whole thing and try to do it in one pass. Alright, when I look at 18 and 42, what will go into both of those numbers? Here's where knowing your facts is going to help you. 6 will go into both of these. So if I divide both numbers by 6, 18 divided by 6 is 3, 42 divided by 6 is 7. Alright, now here I have matching bases with exponents, so we're going to subtract. 8 minus 5 is 3, and I'm going to put it where the largest exponent is. Now here, b to the 4th over b to the 7th. If you subtract 4 minus 7, you get negative 3. So what do you have to do when you have a negative? We're just going to change it, put it right there on the bottom, and it becomes positive. Now, if you do it the other way, where you always subtract the large exponent minus the small one and put it where the largest exponent is, you still get that b to the 3rd right there on the bottom. So that is your final answer. So number 7, we have 39c to the 7th d to the 4th over 24c squared d to the 5th, all squared. Once again, you got options. You can square everything in here and then simplify it, or you can simplify inside the parentheses and then square it. This time I'm going to simplify inside the parentheses and then I'll square everything. It doesn't really matter. When I look at 39 and 24, what number will go into both of those is 3. So if I divide both of these numbers by 3, I get 13 here and 8 on the bottom. Now, simplifying this, c to the 7th over c squared will simplify and be c to the 5th on the top. Now here, d to the 4th over d to the 5th, when I subtract, 5 minus 4 is 1, and I can put it on the bottom so I don't have a negative exponent already. Alright, now let's come over here and write this down simplified so I can look at what I have. Now this is still all squared, which is no problem. Remember, everything in here has to be squared though. So 13 squared is 169. C to the 5th squared is c to the 10th. 8 squared is 64. And d squared is d squared. And then you want to check it, be sure nothing will go into 169 and 64. And it won't, so we're good to go. Okay, this last example, we have this set of parentheses multiplied times this set of parentheses. You can't combine the stuff until you get rid of those exponents that are on the outside. That's what's going to get rid of your parentheses. And since this exponent's positive and this one's negative, you're actually going to have to do it a little bit differently for each one. So let's just look at this one first. I have a negative exponent inside here and I have a fraction. So what I want to do, and like I'm saying, there's a lot of different ways to do this. I'm just going to make this all one big fraction first. So I've got my 1 and my 2. Now m to the negative 2 right now is actually on top. So what would I do if I want to change this to a positive? Well, it's going to have to go to the bottom. So I'm going to go ahead and do that. Now, n to the 3rd is fine. And I don't need this much room. And that's all going to be cubed. So let's go ahead and simplify it down just a little bit more. 1 cubed is 1. And I don't really even need to put that anymore because it has something here. Now, n to the 3rd cubed is n to the 9th. Alright, 2 cubed, 2 times 2 is 4, times 2 is 8. And m squared cubed is m to the 6th. Okay, so that's the simplified version of this. Now let's go over here and work on this. First, I'm going to change this to one big fraction. Because when you have a fractional exponent, it's easier just to flip the whole fraction. So 1 is going to be fine. I don't even have to write it anymore. Let's go ahead and put the 8 here. Now where is m to the negative 1 going to go? On top or bottom? It's going to go on bottom. It has an exponent of positive 1 now, so there's no need to put that. N to the 4th will remain up here, and I still have that negative 2 exponent. Okay, let's just make this positive. And we do that by flipping this. So now I have 8m on the top and n to the 4th on the bottom, and that too becomes positive. When I flipped it, it made this positive. Alright, so now let's just simplify in here. This is not going to change m to the 6th. Alright, 8m squared is 64m squared. And n to the 4th squared is n to the 8th. So, still simplifying. When I have all this together, if I want to put it all on one fraction before I start breaking it down, I can. So let's do 64m squared n to the 9th over 8m to the 6th n to the 8th. Now it's all nice and in order alphabetically, and I can see what I'm fixing to reduce. 64 divided by 8 is 8. M to the 2nd over n to the 6th. Subtract the exponents, that gives you 4, and it's going to go where the largest exponent is, so that's on the bottom. And then n to the 9th minus n to the 8th gives you n, so that stays on the top. So you can see they get a little bit disorganized while you're working on it. Just focus on your rules, you know what those are, and do them one at a time. 2 numbers at the time, 1 rule at the time, and you will be fine. Okay? So let's move on to page 2 in your guided notes. Okay, we're going to wrap this up by looking at polynomials now. A polynomial is when you have a sum or difference of 2 or more monomials. So what is one thing that a polynomial is going to have that a monomial does not? Well, a polynomial is going to have at least one or more plus or minus signs. If you don't have a plus or minus sign in there somewhere, you have a monomial, not a polynomial. So let's look at the vocabulary of polynomials. First, we rank them according to degree. Now, the degree of a polynomial is the highest exponent that's in that polynomial. So all I have to do is run down the exponents. The largest one is your degree. Now, a lot of times when they ask you for degree, they just want the number. Like if you've got an x to the 3rd, your degree is 3. But sometimes some of them have special words. For example, if your highest degree is a 0, then, and that's not even going to be, that's a 1, then that is a constant term. For example, 3x to the 0, which is just 3, that's going to be a constant term. Alright, if you have 1, which you don't see a 1 exponent always, it's understood, that's going to be your linear term. Alright, if you have a 2 for an exponent, there comes your quadratic. You're all familiar with those. When you have a 3, we refer to that as a cubic. When you have a 4, we call that a quartic. And a 5 is called a quintic. But most of the time you're just going to refer to it by the number. Alright, now, how many terms does the polynomial have? Well, if it has 1 term, that's a monomial. 3xy would be an example of that. If it has 2 terms, you guessed it, that's your binomial. 3xy plus 5. 2 terms, that's a binomial. If it's 3, there comes your trinomial. 2x squared plus 3x plus 5 would be an example of that. If there are 4 or more terms, we just call it a polynomial. 4 or more, okay? Now, let's look at some examples of adding and subtracting polynomials. Let's look at sample problem number 9 right here. We need to simplify it and we need to classify it. And when you simplify expressions, that's when you're using your order of operations, and the first step is to get rid of grouping symbols. So I need to get rid of the parentheses. Now, there's 2 ways to eliminate parentheses. You can perform the operation that's in there, or you can distribute what is outside. Now, since I cannot perform this operation, the plus and minus, because I don't have matching terms, I'm going to have to go to the other method. I'm going to distribute what is outside of there. Well, what's outside of this parenthesis? You don't see anything, so it's your understood 1. So when I distribute a 1 into this, nothing's going to change. I just don't want you to think that you can just drop parentheses, because you cannot. You have to have a reason, and our reason is that we distributed the 1 that is outside. Now I'm going to do the same thing here. This has a plus 1 outside of it, so that's not going to change anything. And now I'm free to combine terms. So b squared plus 8b squared is 9b squared. 5b minus 2b is positive 3b. And minus 11 minus 7 minus 18, final answer. Now we need to classify. First, make sure it's in standard form. Do your exponents decrease? They do. I've got a 2, a 1, and what would technically be a b to the 0. Alright, now classify it. What is your highest exponent? A 2. So that means that this is a quadratic. Now how many terms do you have? 1, 2, 3. So that means it's a trinomial. So, final answer, quadratic trinomial. Okay, let's look at this combination of polynomials. We need to get rid of parentheses. Out front of this is positive 1. So when I distribute it, nothing changes. Now, this one's a little trickier because it's got that minus sign there. So when you distribute, you've got to distribute a negative 1 or a minus 1. So this 9 is actually positive right now because it's inside the parentheses, but when I distribute, it's going to become negative 9 or minus 9. When I distribute this, that's going to be minus 3w squared and minus 7w. Now we're ready to combine terms. 3w squared minus 3w squared makes 0, so those are gone. Alright, a positive 2w and a minus 7w gives me minus 5w. And then when I combine negative 6 plus negative 9, I get negative 15. Alright, what's your highest exponent? We're fixing to classify it. What's your highest exponent? It's understood to be 1, so this is a linear. Now how many terms do you have? 2, so it is a linear binomial. So this is number 11. It is subtracted. Alright, now we need to get rid of the parentheses. So the first one, it's positive out here, so we're not going to have to change any of this. But this is going to change everything in this one. It's going to make it the opposite of what it already is. Alright, now let's combine matching terms. Here's a negative 3y squared. Let me just put one line under that. And that can combine with this. Negative 3 combines with negative 4 to give you negative 7y squared. Remember, when you're adding terms, exponents do not change. Exponents change when you multiply terms. When you add terms, exponents stay the same. Alright, here's a y to the third and a 3y to the third. They're both positive. Combine them to get 4y to the third. Then, I don't have anything to combine to the minus 2, and I don't have anything to combine to the minus y. So those are going to stay the same. Let's put this in standard form because the directions do tell you to put it in standard form. Now before, all the ones we did previously, they just happened to land in standard form, so I didn't mention it. But now, this is not in standard form. Standard form means you start with your exponent, your highest exponent first, and you work your way down. What if you have 2 letters that have exponents? Well, then you go alphabetically. So we have only y's here. That's the only one we're going to have to worry about. Our largest exponent is the positive 4y to the third, so that would be first. Next, we have the minus 7y squared. Then we have the linear term y, and then we have the constant. So this is actually in standard form. Alright, now let's classify it. According to exponents, what's your highest exponent? Of 3, which means this is a cubic. Now, how many terms do you have? 1, 2, 3, 4. So it doesn't really have a special name. It's a cubic polynomial. Okay, let's look at example number 12. They are added, so when I distribute what's in front of each set of parentheses, nothing's going to change. So let's see what this looks like. 5k to the third minus k squared plus 7. Now this 4 is negative. So when I distribute a positive 1, is it going to change that? No, it's going to remain negative. So nothing changes. This remains positive, and this one remains positive. All right. Now let's combine terms. Do I have anything that combines with 5k to the third? No, it's going to stay just like it is. All right. My k squared. I have a minus k squared and a plus k squared. So they're just going to cancel each other out. All right, next I have this plus 7 and plus 2. So that gives me plus 9. Then I have that minus 4k left over. Okay, let's get it in standard form. This is the highest exponent, so this will go first. Now this is my next exponent, a 1. They don't have to, sometimes it skips them. And that's what we do. We don't have a k squared, but our next term numerically is going to be that 4k plus 9. Okay, let's classify it. This makes it cubic. How many terms do you have? 3. So this is a cubic trinomial. Now we're going to look at multiplying polynomials. So when you multiply polynomials, what you have to do is be sure that every term in one set of parentheses gets multiplied by every term in the second set. And then you can combine terms. So x times 2x squared is 2x to the third. And x times 6x is 6x squared. And x times that minus 7 is minus 7x. Now let's do the minus 3. Minus 3 times 2x squared is minus 6x squared. Minus 3 times positive 6x is going to be minus 18x. And minus 3 times minus 7 is going to change to positive 21. Okay, let's combine terms. There is no more x to the third terms, so it's going to stay like it is. I can combine a plus 6x squared and a minus 6x squared. They're actually just going to cancel out. All right, minus 7x minus 18x. Since the signs are the same, you add and keep the sign, so that's negative 25x. Remember, when you're adding and subtracting, you use exponents to match, but you don't change them. And then our last term down here is the plus 21. All right, let's check it and see if it's in standard form. And I do have my highest exponent, my next exponent, and my constant term, so I'm good there. Now let's classify it. According to exponents, this is cubic, and number of terms, 3, so this is a trinomial. Okay, let's look at this example. Now, here is your main minus sign. What you actually have is this minus this, because according to PEMDAS, multiplication comes before addition and subtraction. So that's why these two things being multiplied actually make them one term. Even though there's a binomial in here, that parentheses groups it together into one thing. So this is what you're actually dealing with. Let's look first at this set of brackets. When you multiply binomial times a binomial, that's your famous FOIL method if you want to look at it that way. But we're just going to be sure that we multiply this 4t times both of these. So that's going to be 20t squared and 12t. Alright, a minus 1 times 5t gives you minus 5t, and a minus 1 times 3 gives you minus 3. Alright, now here we're going to have to be careful, and I'm actually going to leave that in brackets right now, because that minus sign has to be distributed into all of this but only after I get it simplified. So first, let's multiply 2t times this, and that's going to give me 20. T times t is t squared. And then 2t times minus 9 is going to be minus 18t. Okay? Now, to get rid of the brackets, remember brackets are the same as parentheses. We just use them alternating because it's easier to see the groupings. Brackets have the exact same power, strength, meaning as parentheses. There's really no difference. So to get rid of these brackets, I would distribute what's out here, which is positive, so nothing is going to change here. I'm just multiplying by positive 1 all the way through. Now here, I'm multiplying by negative 1. So everything changes. At this point, this 20 is positive, so the negative is going to make it, the minus is going to make it negative or minus. It is going to change this to a plus. So now I'm ready to go through here and combine terms. A positive 20t squared and a negative 20t squared cancel out entirely. 12t minus 5t is 7t, and then you have 18t, so that's going to give you 25t minus 3. All right, now is it in standard form? Yes, it is. So let's classify this. It is linear because the exponent is understood to be 1, and it is a binomial. Let's look at example 15. We have 4j minus 7k all squared. This is actually a binomial expansion problem, and you see this a lot on standardized tests, so let's pay close attention. If your first instinct is just to square each term in here and come up with 16j squared minus 49k squared, you are wrong. That is not how you square a binomial. When you square the set of parentheses, you have to multiply this whole set times itself. So expanded form of this is 4j minus 7k times 4j minus 7k. And if I had a larger exponent, if I had a 3, I would have to put another one. If I had a 5, I'd multiply 5 of them together. So whatever your exponent is, that's how many times you're going to multiply that set of parentheses times itself. Now, for the multiplication, you're just going to distribute. You could call it full if you want to, but what we're going to do is multiply the first two terms together. That gives you 16j to the second. Then this is going to be negative 28 jk. All right, now let's do the 7k. Negative 7k times 4j is going to be negative 28. Now, you could put kj, but I like to keep my letters in alphabetical order. That way it's easier to combine terms. And remember, multiplication is commutative. So jk is the same thing as kj. So I'm just going to write it like that. And then negative 7 times negative 7 is positive 49 k squared. Now let's combine terms. I don't have another j squared term, so it's not going to change. These two terms can combine, and I get negative 56 jk. And then I have my plus 49 k squared. Now we need to put it in standard form. Standard form is descending order according to exponents. Well, I have a j squared and a k squared. This is a perfect example of what I was telling you about. When you have two letters or more letters, now you default to alphabetical order. So j comes first. We're going to start with j. J squared is my highest exponent. J to the first is my next exponent, and that's all the j's. So now go to your next letter, k. So the next one would be k squared. So this is in standard form. All right, now we're going to classify it according to exponents first, the degree of it. So you look at all the exponents. The highest one is a 2. So that means that this is a quadratic. And then you count your terms. There are 3. So this is a trinomial. Here's example 16. Now we have these three binomials multiplied together. And I don't care how good you are, you can only multiply two things at a time. So, first we're going to multiply the first two together. Now if you were being sharp, you would recognize that this fits your difference of two squares formula, and you could just go ahead and write down the answer, but I'm going to distribute it in case you don't remember that formula. So, we're going to multiply 2v times 2v, that gives us 4v to the second power. 2v times minus 3 is minus 6v. 3 times 2v gives us plus 6v. And positive 3 times negative 3 is minus 9. And I'm going to keep this in parentheses because after we get it simplified, then we're going to multiply it times that binomial. Alright, a minus 6 and a plus 6 cancel each other out. So our simplified version of this is 4v squared minus 9. And that's what I'm talking about. If you had remembered your formula, you could have just skipped to right here. You wouldn't have had to go through that. Alright, once again, we're just going to distribute this into here. 4v squared times negative 3v is negative 12v to the third. And 4v times 1 is positive 4v squared. Alright, negative 9 times negative 3 is positive 27v. And then minus 9 times 1 is minus 9. Is this in standard form? Yes, it is. These go in descending order. So let's classify according to exponents. It has a 3. So this is a cubic. And how many terms do you have? You have 4. So it is a cubic polynomial. Now we're going to multiply trinomial times trinomial. Just two numbers at a time. I just need to make sure that every number in this first trinomial gets multiplied times every number in this one. So let's take it slow and draw our lines. P squared times P squared is P to the 4th. P squared times minus 2P is minus 2P to the 3rd. And P squared times 1 is just P squared. Now let's do our second number. P times P squared is P to the 3rd. P times a minus 2P is minus 2P squared. And P times 1 is P. Alright, let's do our last one. We're going to multiply negative 6 times each one of these things. So negative 6 times P squared is negative 6P squared. And negative 6 times negative 2P is positive 12P. And negative 6 times positive 1 is minus 6. Alright. Now let's go through here and combine terms. Do I have any more P to the 4th terms? Because that's what you're using to match. The variable part with its exponent has to match exactly. Nothing else matches P to the 4th. So I can write it down. Now let's look at this one. Do I have anything that matches P to the 3rd? Well, here's a negative 2, here's 1, and that's it. So negative 2 plus 1 gives you negative 1 P to the 3rd. And you don't have to put the 1 understood. Alright, next let's go with the P to the 2nd powers. I have one here, I have this one, and I have this one. So let's combine all those. 1 minus 2 gives me negative 1, plus a negative 6 gives me negative 7P squared. Now let's see what else we have. We've got this matches this, so that gives us 13P, and then the little 6 down there, there's nothing to go with it. Alright, is there anything else to combine? Let me check that. No. So now we're going to classify it. What's our highest exponent? This is a degree 4 polynomial, which is a quartic. Usually people just refer to it as degree 4, so I'll put both of them down here. Alright, now how many terms do you have? 5. 4 or more is just a polynomial. Okay, this is a pretty simple looking problem on the outset, but it's going to get a little messy because we have two binomials that are squared multiplied times each other. So, PEMDAS, we always use PEMDAS when we're simplifying. Whether you think you are or not, that's what you're doing. So we can't do what's in the parentheses. The only way to get rid of the parentheses is to distribute that 2. And what that means is this binomial squared means 3x plus 1 times 3x plus 1. This binomial squared means negative x plus 4 times negative x plus 4. You can combine these and multiply them together any way you want to. You could do this times this and this times this and then multiply those. But I'm just going to plow my way through it from beginning to end. When I pull these together, 3x times 3x is 9x squared, and 3x times 1 is 3x. 1 times 3x is 3x, and 1 times 1 is 1. And then simplify those middle terms, 9x squared plus 6x plus 1. Okay? Now all of that is going to be multiplied. And you could take this now and multiply it times that, and then come back and get this one and multiply it times all that. But I'm just going to go ahead and do these two together. That's going to give me another trinomial, and then I'll have to multiply the two trinomials together. So here, negative x times x is positive x squared, and negative x times 4 is minus 4x. All right, 4 times negative x is minus 4x, and 4 times 4 is 16. So that's going to give me x squared minus 8x plus 16. Okay, now we're going to have to be careful so we don't lose everything. We've got to multiply this number times all three of these, and this number times all three of these, and this number times all three of these. So, 9x squared times x squared is 9x to the 4. And 9x squared times minus 8x is negative 72x to the 3rd. 9x squared times 16, 9 times 16 is 144x to the 2nd. Alright, now let's do 6x. 6x times 6x squared is 6x to the 3rd. And 6x times negative 8x is negative 48x squared. And 6 times 16, it's going to be positive 96x. And now we're ready for the 1. So nothing is going to change here. So that's going to be plus x squared minus 8x and plus 16. Okay, so now let's go through here and combine like terms. Now there's no other x to the 4th terms, so 9x to the 4th stays like it is. Alright, our x to the 3rd terms, I have a negative 72x and a positive 6x. That's going to give me a negative 66x. Alright, 144x to the 2nd minus 48x to the 2nd plus one more x to the 2nd is going to give me a positive, let me go back, this should have been x to the 3rd. A positive 97x to the 2nd. Then, let me come back, I can combine this one with this one. Positive 96 plus 8 is positive 88x. And then the plus 16 just stands alone. So, just be careful. Think two numbers at the time. Go slowly. Now let's classify it. It is in standard form already. My exponents just fell into place, descending order. So my highest exponent is a 4. That makes this a quartic, not quadratic. Remember, quadratic is when you have the highest exponent of 2. So don't get that confused. And a lot of times they're just going to ask you to put, they want to know the degree in numerical form. So this is a degree 4 polynomial. Since it has more than 4 terms, it's just a polynomial. Okay, now let's look at that word problem. Okay, let's have a look at that word problem. We have an original triangle with a base of 3x plus 7 and a height of 5x minus 1. And they tell us our new triangle has a base that is tripled. So when I multiply 3 times 3x plus 7, I get 9x plus 21. The height is doubled, so when I double that height, I get 10x minus 2. They want me to find the difference in the areas of the two triangles. Well, the formula for the area of a triangle is 1/2 base times height. Now, when I find the difference, I'm going to want to subtract the small one from the larger. Well, obviously the second one is larger. So what I'm looking at here is A2 minus A1, the area of number 2 minus the area of number 1. So let's find these two areas. All right, area of number 1 is going to be 1/2 times the base, which is 3x plus 7, times the height, which is 5x minus 1. When you have a series of numbers multiplied together, you don't have to do them from left to right. Multiplication is commutative. You can pick and choose and combine them two at the time until you get them all multiplied. Sometimes just going left to right is the easiest thing, but in this case, since I have a half here, when I multiply by a half, that's going to create a fraction or a decimal. And I really don't want to have to deal with that decimal until the end. So what I'm going to do is I'm going to multiply these two first. All right? So I'm going to save my 1/2 till the end. 3x times 5x is 15x to the second. 3x times minus 1 is minus 3x. 7 times 5x is 35x. And 7 times negative 1 is minus 7. Now, a minus 3x and a plus 35 gives you a plus 32x. Now let's multiply through by the 1/2. Now remember, it's the same thing as dividing by 2. So when you divide 15 by 2, you're going to get 7.5 x squared. 1/2 times 32x will give you 16x, and 1/2 times minus 7 is minus 3.5. So the area of my triangle number 1 is 7.5 x squared plus 16x minus 3.5. All right. Now I'm going to erase this because I don't want to run out of room. Now the area of triangle number 2, same formula, 1/2 times the base, which is 9x plus 21, times the height, which is 10x minus 2. Now, thinking smart again, I'm always going to assess my situation. This one is different. In the last part, the last area, I didn't have a binomial that had even numbers. This time I do. I can go ahead and multiply the 1/2 times this binomial, and that's going to get rid of the fraction and just leave me whole numbers. So let's do that first. Now I'm going to save 9x plus 21 till the end. 1/2 times 10x is 5x. 1/2 times minus 2, minus 1. Now I'm going to multiply. 9x times 5x is 45x squared. And 9x times minus 1 is minus 9x. 21 times 5x is positive 105x, and 21 times that is negative 21. Combine these middle terms, minus 9 and a plus 105 gives you a positive 96x. So the area of triangle number 2 is 45x squared plus 96x minus 21. Okay, now we just need to subtract, and what I'm going to do is I'm just going to erase that, and let's put this in parentheses, put a minus, and we'll just subtract straight down. So first of all, 45 minus 7.5 x squared gives you 37.5 x squared. 96 minus 16 gives you a positive 80x. And 21 minus negative 3.5, that's going to change to plus a positive, so that's going to be a minus 17.5. And that is the difference between the areas of triangle 2 and triangle 1.